Have you ever stared up at the night sky and wondered what secrets still hide in the farthest corners of our solar system? While the spotlight often falls on Mars, Jupiter, or Saturn, there's one planet that remains a mysterious, icy enigma, sitting quietly over 1.8 billion miles from Earth. Uranus. It's pale, tilted, cold, and until recently, it was one of the least explored worlds in our cosmic neighborhood. But that just changed. In April 2025, scientists used a rare cosmic event, something called a stellar occultation, to peer inside Uranus in ways we haven't managed in over 3 decades. And what they found could change everything we thought we knew about this bizarre ice giant. Today, we're giving you a front-row seat to the observation, the science behind it, and the fascinating revelations about a planet we're only just beginning to understand. Why Uranus matters. Let's start with the big question. Why Uranus? It's the 7th planet from the Sun. It orbits once every 84 years. And if we're being honest, it's often treated as the forgotten middle child of the outer solar system. There's only been one mission to Uranus, Voyager 2 in 1986. It flew by in just a few hours, capturing a handful of images and basic data before continuing on its journey. Since then, we've had no close-up missions, no orbiters, no landers, just Earth-based observations, blurry, distant, and incomplete. But Uranus isn't boring. It's strange. Its axis is tilted a full 98 degrees, meaning it basically rolls around the Sun on its side. Its magnetic field is wildly off-center. It has rings, moons, and an atmosphere laced with icy methane and hydrogen. And inside, we barely know anything, which is why this new observation matters so much. What is a stellar occultation? So how do you observe a planet like Uranus in detail, from nearly 2 billion miles away? That's where a phenomenon called a stellar occultation comes in. A stellar occultation happens when a planet passes directly in front of a distant star, temporarily blocking the starlight from reaching Earth. Think of it like a miniature eclipse, but on a galactic scale. Here's what makes it powerful. As the star's light passes through the planet's atmosphere, some of it bends, scatters, or dims in very specific ways. By carefully measuring how the light changes, second by second, fraction by fraction, scientists can reverse engineer the structure of the planet's atmosphere. It's like using shadows to map the shape of an invisible object. But here's the catch. These events are rare and precise. The alignment has to be nearly perfect. The planet, the star, Earth, and the observatory all have to be in the right place at the right moment. In April 2025, that perfect moment arrived. For the first time in 33 years, Uranus passed in front of a bright star, giving NASA, ESA, and observatories around the world a chance to conduct the most detailed atmospheric study of Uranus since Voyager 2. How the observation worked. The April 2025 occultation was tracked using a network of telescopes across multiple continents, each stationed along a narrow observational path where the event would be visible. Scientists coordinated months in advance, predicting the star's trajectory down to the second. On the night of the event, telescopes were locked in, sensors calibrated, and data streams humming. As Uranus passed in front of the starlight dimmed and brightened in a precise, timed sequence. The first clue? A gradual dimming of light as the star's rays passed through the outermost layers of Uranus's atmosphere. Then, an almost complete blackout when the star was fully blocked. And finally, a mirror image of the process in reverse as the star re-emerged on the other side. Every flicker in brightness told a story. By analyzing those changes with high-resolution photometry and spectroscopy, scientists could infer the temperature, density, and composition of each layer of Uranus's upper atmosphere. And what they discovered surprised even the most seasoned planetary scientists. What NASA found. First, they confirmed what previous models had only guessed. Uranus has a complex layered atmosphere with sharp temperature gradients and unexpected dynamics. But even more fascinating, they found signs of seasonal activity. That's right. Uranus, despite its distance from the sun and freezing temperatures, experiences slow, extreme seasons due to its tilted axis. The data showed subtle shifts in heat distribution that suggest atmospheric circulation is more active than previously thought. This hints at internal processes, possibly convection from deep within the planet's interior. Second, they detected haze layers that are thicker and more structured than expected. These hazes are likely made of hydrocarbons formed from sunlight breaking apart methane in the atmosphere. But the formation patterns and their vertical layering don't fully match what we see on Neptune or Saturn. Something strange is happening in Uranus's skies. And then there were the rings. The occultation also revealed sharper measurements of Uranus's faint, dusty rings. It turns out these rings might be much more dynamic, possibly shifting or replenishing with material from unseen moonlets or interactions with the planet's magnetosphere. One thing is clear: Uranus is not dead. It's active, layered, and evolving. Why it took 33 years? You might be wondering, why did we wait over 3 decades for this? Well, occultations like this depend on chance alignments. The star has to pass behind the planet from our point of view. And it has to be bright enough, and Uranus has to be close enough for us to get usable data. These conditions are rare. The future of Uranus exploration. That's right, a new mission is coming. NASA's Uranus Orbiter and Probe, currently in development for the early 2030s, aims to deliver the first long-term study of the ice giant. It will orbit the planet for years, drop a probe into its atmosphere, and study its magnetic field, rings, moons, and internal structure in detail. But until then, stellar occultations like this one are the closest we can get to understanding the mysteries of Uranus. And each one gives us precious clues, helping us prepare for the moment we finally arrive. So what did we learn from this rare glimpse? That Uranus, long ignored and understudied, is a dynamic world with secrets waiting to be uncovered. Secrets we're only just beginning to unlock. From swirling haze layers to shifting rings, from seasonal winds to deep interior mysteries, this icy planet is no longer silent. It just took the passing of a star and the eyes of Earth turned skyward to hear it speak. That even the most forgotten places in the universe still matter. And they still have stories to tell. If you found this video fascinating, subscribe to Whispers of Fiction for more cosmic revelations, where science meets wonder and the unknown gets just a little more known. And tell us in the comments, should NASA prioritize a mission to Uranus? Or are we missing even greater mysteries somewhere else? Until next time, keep watching the stars.